Hello. Solid. Hope you guys can hear me. Perfect. Thank you so much, guys, for coming out here for this talk. Yeah, we'll keep it very short and simple, and kind of just like go through some stuff people have been chatting about in the space for quite a bit, and kind of just like kind of talk about a very nuanced thing that we get like we rarely get an opportunity to talk about. Yeah. And that's the problem of interop. Yeah. So I think interop so far has been like an important problem, and going forward, it's becoming more and more important with like everything becoming an L2. I'm actually kind of writing a very interesting blog where I'm trying to kind of make it as a thought experiment about like what if every contract on L1 was an L2, right? What's the kind of future that we can unlock with some of that stuff? But regardless, we are kind of heading into a very like multi-layered future, and interop is becoming a very important problem to solve. And I kind of like to frame the whole kind of interop problem as a messy mesh problem, right? It's not simple, it's not clear, it's a mesh, right? And we need like solutions that can help developers and users kind of navigate this messy mesh, yeah? And I'd like to kind of frame the whole problem in that fashion. So I'll kind of just like talk about why I think it's a messy mesh problem, and what are some like potential solutions to kind of navigate this whole thing. So just to kind of start things off, a quick intro. I'm Vaibhav. I also go by VC. I lead socket.tech, which is an interop project. So yeah, there is some bias, of course. I've built Polygon POS before. I built one of the first ZK rollups back in 2019. I was at Ethereum Foundation for about a year. Built the cheapest optimistic rollup there. So yeah, I've been building bridges for a while, and that's how I kind of came to this conclusion. I think let's just start with a simple concept, right? We are all kind of building protocols, building applications, and we all know the ideal user experience is where people don't have to care about what chain they are on, right? Which kind of in some sense means that users should not care what chain they are on. And it kind of begs the question, is all block space the same? To a user, does it really matter if he's on an L2? Or if he's on a alt L1 or on AVAX or on BNB, right? The ideal UX experience says it should not matter. So who should care about this stuff? It's the developers, right? It's the developers kind of optimizing, looking at the space and kind of optimizing the user experience, and then the users at the end should not care about what chain the protocol is on, but the developers should really care. And it's like, it's definitely not true that all block space is the same. L2 block space is very different than AVAX block space. BNB block space is very different than Polygon block space. And there are like multiple reasons for this. Block space differentiation comes from like projects that are deployed on that block space. So if you're building something that composes with Aave, and if Aave is not present on that block space, then that block space is not the same as, let's say, Polygon, right? Because Polygon has Aave deployed on it, and you as a developer, you can copy paste your contract on Polygon and you'll be good to go, right? So all block space is definitely not the same, right? And I kind of want to try and find out like where is the truth, because sometimes block spaces are same and sometimes they are not. So I want to kind of dive a little bit deep into this and understand what makes block spaces the same and what makes them different. So I think zooming out, we're kind of heading into this place where like we kind of start looking at the ecosystem as ValueNets. This is like very close to how internet was. Everyone was building their own subnet back in the day. I think we are kind of going in the same direction right now. We're seeing like different ValueNets. I'm not sure if the text is visible, but not to worry. I'll be kind of going through everything. So I think like we are starting to see these like clusters form, and the basis of this cluster formation is the bridging or the interop, right? Let me just walk you through like some quick examples, right? So we have an Ethereum cluster, which is Ethereum L1 and all the rollups deployed on top, right? So what makes this the cluster is that all of these rollups have a very secure bridge that connect the rollup to the Ethereum, right? So this very secure bridge that an L2 kind of connects with the L1 on, this makes a system part of this cluster, right? So that's the Ethereum cluster, right? Ethereum, L2s, everyone has like very secure, very efficient interop. we also have a Cosmos cluster, which is a bunch of like app chains connected via IBC, which is one of the most like trustless way to do like cross-chain communication, right? So now, why am I calling this a cluster? Because you could roll out a Cosmos chain tomorrow, and you would have very trustless communication with all the other existing protocols built on the Cosmos stack, right? So these like the IBC is what kind of makes Cosmos cluster a cluster, right? We are also kind of starting to see this whole kind of like Polygon or OP stack cluster, right? So what makes this the cluster, right? So the idea is like OP stack will have shared sequencers, which will kind of offer like better interop to projects building on the OP chain, right? So again, right, this like shared sequencing service that offers better interop. This is how we are defining the OP cluster, right? So kind of like zooming out, it looks like we are defining clusters based on bridges, right? Based on how seamless the interop is. And so far, all the attempts at like solving the interop problem have been very global, right? So if you're kind of in this like context-based world where communication is like communication between two chains depends on like if you're part of the cluster or not, then we literally cannot have like a global interop solution, right? So as a yeah, the quick TLDR here is like clusters are defined by how seamless communication is between like two layers in that particular cluster, and there cannot be like a single bridging model that exists both inter and intra cluster, right? Because things are very different. You can't expect a bridging solution that operates between L2s to kind of be as secure as connecting an L2 to, let's say, AVAX or BNB or whatever, right? And yeah, like at the end, like interop is a very like mesh problem. Like all of this looks like a mesh from a very 1,000 feet view. So yeah, like this is all messy, right? This is all very like untidy. So as a developer, as a builder, what should you do, right? So interop solutions are essentially like chain abstraction tech or this mesh abstraction tech, right? They're supposed to kind of allow developers to build on top of these chains, get users from multiple chains using their protocol, but without exposing this like complexity of the mesh. So over here, I'm trying to kind of think about like what does like a ideal interop stack look like? And in my opinion, the ideal interop stack looks like something that allows developers to leverage the roll-up native bridges wherever it's possible. If they want to do something, cross L2. If a protocol is building on L2 and you kind of go to them and you offer them this like global interop solution that uses like a validator set or something, then building on L2 makes no sense. So if a developer is building on L2 and you want to do something like across L2s, you want something that's as secure as Ethereum. Otherwise, what's the point of going to an L2, right? So an ideal interop solution kind of leverages the properties of the cluster wherever it's possible and allows people to do like trust minimize like inter-cluster bridging wherever it's not, right? So the ideal interop solution allows you to use like Ethereum security between rollups. It allows you to use IBC between Cosmos chains and so on, right? So I think the modular bridges are kind of the right way to kind of solve this whole problem, where you could design your protocol independently about thinking about bridges. You could just kind of build your application on this application layer, and these like modular bridges as a solution, these kind of optimize for context wherever it's possible. These solutions will automatically, kind of route you guys through the native bridge wherever it's efficient. It will automatically route you through, a more trust minimized bridge wherever it's possible, right? So we've built a part of this and we call it, so we built something like this for asset transfers across chain and we call it bungee.exchange. Let me quickly, kind of show you a demo to kind of just like hone in why like you need multiple bridging solution to exist together to kind of have the most efficient user behavior or like developer experience, right? I don't know, for some reason my screen over here is like rotated, so let me just try. Yeah. Um, have any of you used Bungee.exchange before, by the way? No? Oh, you have? Nice. Solid. Solid, yeah. So it's, I don't know, for some reason the screen is like rotated on my end, so I won't be able to kind of show it. But if you go to Bungee.exchange right now, it kind of asks you like, what do you have on this chain and what do you want on this chain? And it will basically present you with like multiple ways to do it, right? Based on like what you want to optimize for. And if you kind of want to do something Ethereum, like if you want to send an asset from Ethereum to Arbitrum, it will kind of show you Arbitrum native bridge as the best way to do that, right? Because it's safe, it does not cost any bridge fees. You just only have to give like gas fees on Ethereum and that's it. But if you want to do something like Arbitrum to Optimism, it will automatically route you through like a third-party like liquidity-based bridge, right? Because there is no direct connection between Polygon, Optimism, and Arbitrum, right? So this kind of modularity allows people to kind of come to this one single place and have the best DevX, UX. They don't have to think about bridges. They just kind of connect to this, and this mesh kind of takes care of everything that's happening underneath the hood. Yeah, so TLDR is a mesh with a routing layer on top. That's the kind of ideal DevX, UX that you want to go for. And yeah, I think my time is up, but I'm outside, happy to chat. Thank you so much, guys.